Okay, this is a calorimetry video about how to find the specific heat of a piece of metal or some object. Anyway, so this is to determine the specific heat. Basically, the student is putting a hot piece of metal into some cold water. So whenever you get a problem like this, you want to make a list. You want to make the water list and you want to have the metal list. And what you're going to need to know for both of them are what's ever in the Q equals MC delta T equation. Q M C T I T F change in temperature. That's the Q. That's basically this Q equals MC delta T equation. All the possible variables. Same thing for the metal. Okay, so you make a list of the givens. And then you look at them, and so to determine the specific heat of the metal, the student places 100 milliliters of water. Well, 1 milliliter of water equals 1 gram, so we're going to call that 100 grams of water. And the specific heat of water, we're going to call 4.18 joules per gram degrees Celsius. That's a given. We know that. Okay? So the water is at 15 degrees Celsius. 15 degrees Celsius. The student adds a 45 gram piece of metal. So the mass of the metal is 45 grams. At 100, the metal is at 100 degrees Celsius to the water. The temperature of the water in the calorimetry increases up until 18. So the water went from 15 to 18. So the change in temperature is final minus initial. That's 3 degrees Celsius. Now, one thing that's always important to know about these calorimetry problems is that the final temperature of the water and whatever you put in the water, they're going to be the same number. Therefore, the change in temperature, though, is going to be 18 subtract 100. It's always final minus initial. So the temperature of the metal change is negative 82 degrees Celsius. Final minus initial. Okay, now it says, what is the specific heat of the metal? So we're looking for C. So here's what we need to do for the metal. To get C, we're going to need to know what Q, and we're going to have to divide that by M delta T for the metal. The problem is we don't know Q, and there's no way to find it without knowing C. But we do have enough information. We can take the water data, and we can find Q for the water by doing Q equals MC delta T for the water. Because the Q for the water is going to equal, in magnitude anyway, not sign, the Q for the metal. We'll talk about the sign in a second. So we're going to plug in the numbers. For the water, Q equals 100 grams times 4.18 joules per gram degrees Celsius times the change in temperature, which will be 3 degrees Celsius. So Q will equal, if I do that math, 100 times 4.18 times 3, that equals 1,254 joules. Okay, the water gained 1,254 joules. See, that's a positive number. The energy's going in. That must mean that the metal lost the same amount. To show that it's lost, you just put a negative sign there. The metal is cooling down. The energy's going out. Now, what we can do is we can just take this information for the metal and plug it into our C equation. C is equal to Q, a negative 1254 joules, divided by the mass of the metal, not the water though, now the metal. And that's going to be multiplied by the temperature change. That's negative 82 degrees Celsius. So if we take 1254, divide by 45, divided by 82, I end up getting that the specific heat of this metal is equal to a 0.33 joules per gram degrees Celsius. Okay, two negatives make a positive. Your C values will always be positive. Remember when you're pushing the buttons on the calculator, you would take 1254 divide by 45, divide by that 82. Okay, here's another problem. I would like you to first identify the givens and pause the video and try to solve it yourself and see if you can get the right answer. Then start the video back up and I'll do it. Okay, so to determine the specific heat of the metal, the student places 200 milliliters of water. Okay, well they're trying to get the specific heat of the metal, so you know that they're going to be doing this equation. C is equal to Q over M delta T. That's the equation they're going to be using. Okay, let's identify the givens. 200 milliliters of water, that's going to be 200 grams of water. Okay, at 25 degrees Celsius, okay, in a calorimeter, the student adds a 75-gram piece of metal. At 90, the initial temperature of the metal is 90. Oh, it's at 99. I wrote down 90. 99. That would have thrown me off. Okay, 99 degrees Celsius. The temperature of the water in the calorimeter goes up to 26.5. So it went from 25 to 26.5, so that's a 1.5 change in temperature. We know that water has a specific heat is given 4.18 joules per gram degree Celsius. Okay, we're trying to find the specific heat of the metal. We know that the final temperature in calorimetry, those numbers are always going to be equal. So we can just transfer the 26.5s over there. And then if we take, to do the change in temperature, we take the final minus the initial, we get a negative 72.5 degrees Celsius. Now what we can do to solve for the specific heat of the metal, we have to know Q, but there's not enough information. But we can use the Q from the water. So water is going to be Q equals MC delta T. Q equals the mass of the water times the specific heat of the water times the temperature change, 1.5, of the water. And so Q is going to be an energy number. It's going to end in joules. So 200 times 4.18 times 1.5. I get 1254. Okay, so the water gained 1254 joules of energy. Well, it got it from the metal. So the metal just lost, you just make it negative, it lost that much. Now we can go over here for the metal, and we can plug this in for the metal. C equals Q, a negative 1254 joules, divided by the mass of the metal. Now we're using all metal data, times the temperature change of the metal, 72.5 degrees Celsius. So if we take 1254, divide by 75, divide by a negative 72.5, we end up getting 0.23. So the specific heat of this metal is, I got 0.23 joules per gram degree Celsius. That would be the final answer. All right, that's it for that video.